In the velvet tapestry of the twilight sky, one celestial jewel often outshines all others. It is not a star, but a world. Venus, the second planet from the Sun, has long captivated humanity with its dazzling brilliance and profound mystery. From our terrestrial viewpoint, it never strays far from the Sun, gracing our skies as the elegant morning star at dawn or the radiant evening star at dusk. This celestial dance, dictated by its interior orbit, means it is forever bound to the Sun's glow, a constant companion to sunrise and sunset. Its brightness is legendary, a result of its proximity to Earth and its thick, highly reflective cloud cover. These clouds, composed not of water but of corrosive sulfuric acid, reflect about 75% of the sunlight that strikes them, making Venus the most luminous object in our night sky after the Moon. For millennia, before we knew its true nature, we simply gazed in wonder at its unwavering light, a beacon in the gathering dark. It is no surprise that our ancestors, enchanted by its splendor, named it for their most cherished deity of love and beauty. Venus. The name itself evokes images of grace, desire, and perfection. Across cultures, this brilliant light was associated with powerful female figures. To the Babylonians, she was Ishtar, queen of heaven. To the Greeks, Aphrodite. This celestial body was a mirror for our highest ideals of feminine allure. And so, for centuries, a beautiful paradox was born. Venus, the planet, paradoxically embodies both this divine allure and a terrifying, unimaginable hostility. It is a world of two faces, the serene goddess we see from afar, and the raging demon we have discovered up close. This profound duality is the heart of the Venusian story, a tale of cosmic deception where exquisite beauty veils a brutal, unforgiving reality. For most of human history, the secrets of Venus were locked away beneath its impenetrable cloud tops. The first person to glimpse a clue to its true nature was Galileo Galilei. In 1610, when he turned his rudimentary telescope towards the planet, he discovered that Venus exhibited phases, just like our moon. This observation was revolutionary, providing critical evidence for the Copernican model of a sun-centered solar system. Yet, even Galileo's telescope could not pierce the veil. The planet remained a featureless, cloud-shrouded disk. This mystery fueled the human imagination for the next 3 centuries. With no surface visible, science fiction writers and even some astronomers envisioned a world of warmth and water, a younger Earth perhaps, teeming with exotic life beneath its misty skies. They dreamed of vast oceans, lush jungles, and swampy landscapes, a tropical paradise hidden from our view. The dream of a tropical Venus was shattered in the mid-20th century with the dawn of the space age. The Soviet Union, in particular, made Venus its primary target. Their Venera program was a relentless, heroic effort to conquer the planet. Probe after probe was launched, each one failing in the unexpectedly harsh environment. Then, in 1967, Venera 4 finally managed to send back data as it descended. The readings were shocking. The atmosphere was not the gentle mist of imagination. It was a thick, choking blanket of carbon dioxide, 90 times denser than Earth's. The pressure was immense, and the temperature was scorching. Later missions that successfully reached the surface survived for mere minutes, but it was long enough to send back the first and only images from the Venusian landscape. They revealed a world of crushing pressure, searing heat, and acidic clouds. The surface temperature hovers around 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is over 90 times that of Earth at sea level, equivalent to the pressure found a kilometer deep in our oceans. The goddess of love was, in reality, an inferno. Yet long before our probes confirmed its hellish nature, ancient civilizations understood Venus's power. They tracked its movements with astonishing precision, embedding it into their calendars, myths, and omens. The Maya, in particular, were master astronomers of Venus. Their sacred book, the Dresden Codex, contains highly accurate tables charting the planet's 584-day cycle, aligning it with their own ritual calendar. They knew its pattern so well they could predict its position in the sky for hundreds of years into the future. For the Maya, Venus was not a gentle goddess, but a fearsome war deity, Kukulkan or Quetzalcoatl. Its appearance as the morning or evening star dictated the timing of rituals, coronations, and even wars. They revered and feared its power, understanding on a deep cultural level the duality that we would only later confirm with science. This ancient wisdom saw the two faces of Venus, the bringer of light and the omen of conflict, a symbolic reflection of the planet's true nature. Today, planetary scientists regard Venus as Earth's twin gone awry, a planet that serves as a stark, cosmic warning. In the grand scheme of the solar system, the two worlds are remarkably similar. Venus is about 95% of Earth's diameter and 81% of its mass. It's our closest planetary neighbor, formed from the same nebular dust in the same region of space. It is almost certain that early in its history, Venus was much more like Earth. Scientific models strongly suggest it once had a temperate climate and vast oceans of liquid water. It may have been habitable for billions of years, far longer than life has existed on Mars. So what happened? The answer is a catastrophic climate shift known as a runaway greenhouse effect. Being slightly closer to the sun, Venus received more solar energy. As its oceans slowly evaporated, water vapor, a powerful greenhouse gas, filled the atmosphere, trapping more heat. This created a vicious feedback loop. More heat led to more evaporation, which led to a thicker atmosphere that trapped even more heat until the oceans boiled away completely, and the carbon locked in the planet's rocks was baked out into the atmosphere, creating the suffocating, high-pressure inferno we see today. Venus transformed from a potential paradise into a planetary hellscape, and understanding how and why this happened is one of the most critical goals in planetary science. Understanding Venus is not just about decoding its geology or its bizarre, super-rotating atmosphere that whips around the planet in just 4 Earth days. It's about confronting the profound fragility of planetary habitability. Venus is a natural laboratory for climate science, a case study of what happens when greenhouse gases go unchecked on a terrestrial planet. By studying our twisted sister world, we learn more about the delicate balance that allows life to thrive on Earth. It forces us to ask difficult questions. Are the forces that doomed Venus unique, or could a similar fate in some form await our own world? The study of Venus is a journey into the heart of planetary evolution, a quest to understand the forces that shape worlds, create havens, and forge infernos. It is a story that is far from over, a story of enduring mystery that continues to call us back to the veiled planet. For centuries, Venus has been called Earth's twin, a tantalizingly similar world veiled in mystery. This comparison begins with its most fundamental physical properties. Venus is nearly identical to Earth in size, with a diameter of about 12,104 kilometers, a mere 600 kilometers less than Earth's, making it just 5% smaller. This striking similarity in scale suggests they were born from the same primordial materials in the same neighborhood of the early solar system. But the similarities are more than skin deep. When we consider mass and density, the twin analogy holds. Its mass is 81.5% that of Earth, leading to a surface gravity that is about 90% of what we experience. If you could stand on the Venusian surface, you would feel noticeably, but not dramatically, lighter. This proximity in mass and size results in a density of 5.24 grams per cubic centimeter, only slightly less than Earth's. This subtle difference hints at a slightly different internal composition, perhaps a smaller iron core or a different ratio of heavy elements. The first clue that beneath the surface, the two worlds began to diverge. Venus follows a path around the Sun that is the most circular of any planet in our solar system. Orbiting at an average distance of 108 million kilometers, or 0.72 astronomical units, it receives nearly twice the solar energy that Earth does. This relentless bath of radiation would prove to be a critical factor in its dramatic evolution. It completes one full revolution every 225 Earth days, making its year significantly shorter than our own. Because its orbit lies entirely inside of Earth's, we only ever see Venus in the hours surrounding sunrise or sunset, a celestial beacon that has earned it the ancient titles of the morning and evening star. Its placid, predictable orbit, however, belies a rotational dynamic that is one of the most bizarre in the known cosmos. While almost every other planet spins counterclockwise on its axis, Venus spins backwards. This retrograde rotation is a profound anomaly. What could have caused a planet-sized body to defy the angular momentum of the nebula from which it formed? One leading theory posits a cataclysmic event deep in its past, a collision with a massive planetesimal that was powerful enough to not just tilt the planet, but to completely reverse its spin. A more recent and equally compelling hypothesis points to Venus's own atmosphere as the culprit. Over billions of years, the immense gravity of the Sun could have tugged on the planet's incredibly dense atmosphere, creating powerful thermal tides. This constant, massive-scale friction between the thick, churning atmosphere and the solid planet below could have acted as a colossal brake, gradually slowing its original rotation to a halt, and then ever so slowly, causing it to spin in the opposite direction. This process has left Venus with the longest day of any planet in the solar system. It takes a staggering 243 Earth days to complete a single rotation on its axis, which means paradoxically, a Venusian day is longer than its 225-day year. However, because it is rotating backwards as it orbits the Sun, the time from one sunrise to the next, its solar day, is significantly shorter, at about 117 Earth days. For all of human history, the true face of Venus was hidden beneath an impenetrable, uniform blanket of pale yellow clouds. It wasn't until the age of space exploration, and specifically NASA's Magellan mission in the early 1990s, that we finally pierced the veil. Using powerful radar, Magellan meticulously mapped 98% of the planet, revealing a world shaped by fire and immense geological forces. The surface is dominated by vast, smooth volcanic plains, covering some 80% of the globe. These are punctuated by thousands of volcanoes, most of them broad shield volcanoes, and two massive highland regions, or continents. In the north lies Ishtar Terra, a plateau the size of Australia, home to the planet's highest mountains, the Maxwell Montes. Near the equator sprawls Aphrodite Terra, a landmass as large as South America. Unique to Venus are the tesserae, complex regions of highly deformed terrain with intersecting ridges and grooves, believed to be the oldest parts of the Venusian crust. The planet's surface is geologically young, estimated to be only 300 to 600 million years old. Its thick atmosphere vaporizes all but the largest incoming asteroids, and the sparse, random distribution of impact craters suggests the entire planet may have undergone a catastrophic global resurfacing event that wiped the geological slate clean. Recent data even hints at active volcanism, a world still very much alive. Beneath this volcanic landscape lies an interior we believe is broadly similar to Earth's, with a metallic core, a rocky mantle, and a crust. But a critical difference lies at its very center. Venus's achingly slow rotation is likely why it fails to generate a global magnetic field. Without this protective shield, the solar wind has been free to strip away lighter elements from its upper atmosphere for eons, a key process in its transformation from a potential twin to the hostile world we see today. That hostility is driven by its atmosphere, a crushing sea of gas 92 times more massive than Earth's. It is composed of 96.5% carbon dioxide, the perfect ingredient for a runaway greenhouse effect. Scientists believe that early Venus may have had liquid water oceans, but being closer to the Sun, these oceans began to evaporate, filling the atmosphere with water vapor, another potent greenhouse gas. This trapped more heat, which caused more evaporation in a vicious feedback loop until the oceans boiled away entirely. Ultraviolet radiation then broke the water vapor apart. The light hydrogen escaped to space, while the oxygen reacted with carbon from the rocks, permanently locking it into the atmosphere as CO2. The result is a surface temperature averaging a uniform 465 degrees Celsius, or 869 degrees Fahrenheit, hot enough to melt lead. This inferno is hotter than the surface of Mercury, despite Venus being much farther from the Sun. The heat is trapped and distributed globally by the thick atmosphere and the planet's famous clouds, which are not made of water, but of corrosive sulfuric acid, forever hiding the blistering, volcanic, and alien world that Earth's twin has become. Venus's surface is a testament to volcanic activity. Over 80% of the terrain consists of basaltic plains formed by lava flows. Massive shield volcanoes like Mont Mons and Sif Mons rise from these plains, suggesting a geologically active past and possibly present. Unlike Earth, Venus lacks plate tectonics, but its crust may undergo episodic overturns, resurfacing the planet in catastrophic events. Tesserae, complex ridged highlands, are among the oldest features on Venus, possibly predating global resurfacing. Their chaotic structure hints at tectonic deformation and ancient geological processes. Impact craters are relatively few and evenly distributed, implying a young surface, likely less than 500 million years old. Venus's atmosphere is a dense, choking blanket of carbon dioxide, with trace amounts of nitrogen and sulfur compounds. At the surface, pressure reaches 92 times that of Earth, equivalent to being 900 meters underwater. The clouds, composed of sulfuric acid droplets, reflect sunlight efficiently, giving Venus its high albedo and brilliant appearance. Above the clouds, winds reach speeds of 360 km/h, circling the planet in a phenomenon known as superrotation. This rapid movement contrasts sharply with the planet's sluggish rotation and remains a subject of intense study. The greenhouse effect on Venus is extreme. Sunlight penetrates the clouds, heats the surface, and the infrared radiation is trapped by CO2, creating a runaway feedback loop. Unlike Earth, Venus lacks a significant intrinsic magnetic field. This absence is puzzling, given its similar size and presumed iron core. Theories suggest that Venus's slow rotation prevents the dynamo effect needed to generate a magnetic field. Instead, Venus has an induced magnetosphere, formed by interactions between the solar wind and its ionosphere. Internally, Venus is believed to have a layered structure, a silicate mantle, and a metallic core, possibly liquid. However, without seismic data, these models remain speculative. The lack of a magnetic shield exposes Venus's atmosphere to solar stripping, though its massiveness helps retain most of it. Venus and Earth began as twins, similar in size, composition, and proximity to the Sun. Yet their paths diverged dramatically. Earth developed oceans and life. Venus became a furnace. The key difference lies in atmospheric evolution. Venus likely had water early on, but solar radiation and volcanic outgassing led to evaporation and CO2 accumulation. Without plate tectonics or a magnetic field, Venus couldn't regulate its climate. Studying Venus helps scientists understand planetary habitability and the delicate balance required for life. It also informs exoplanet research, as many discovered worlds resemble Venus more than Earth. Venus is a reminder that proximity to the habitable zone is not enough. Internal dynamics and atmospheric chemistry are crucial. Venus has been a celestial muse for millennia. The Babylonians called it Ishtar, goddess of love and war. The Maya tracked its cycles with astonishing precision, linking them to rituals and prophecies. In Roman mythology, Venus was born from sea foam, embodying beauty and desire. Yet her planetary counterpart is anything but gentle. The dual appearance of Venus as morning star, Lucifer, and evening star, Hesperus, inspired philosophical debates and poetic metaphors. In Christian tradition, Lucifer's fall from heaven echoes Venus's descent below the horizon. The planet's brilliance and elusiveness made it a symbol of both enlightenment and deception. Venus was the first planet visited by spacecraft. The Soviet Venera program achieved historic milestones. Venera 7 became the first probe to land on another planet in 1970, and Venera 13 sent back the first color images of the surface in 1982. These missions revealed a rocky, orange-hued terrain and confirmed the incredibly harsh conditions. NASA's Magellan mission that went from year 1989 to 1994 used radar to map 98% of Venus's surface, unveiling its geological diversity. Japan's Akatsuki, launched in 2010, studies atmospheric dynamics and cloud patterns. Future missions, NASA's Da Vinci Plus and Veritas, ESA's Envision, aim to probe Venus's atmosphere, surface, and internal structure with unprecedented detail. Venus is more than a scientific curiosity. It's a planetary mirror. Its fate warns of the dangers of unchecked greenhouse effects and atmospheric instability. As Earth grapples with climate change, Venus offers a sobering glimpse of what could happen if feedback loops spiral out of control. Philosophically, Venus challenges our assumptions about beauty and danger. It is a world that dazzles from afar, but punishes those who approach. Its veiled surface and hostile climate evoke themes of forbidden knowledge and cosmic irony. Venus is a reminder that appearances deceive and that understanding requires courage and persistence. It is a world that demands respect, not for its gentleness, but for its power and mystery. Venus, our celestial neighbor, has forever been a paradox. From Earth, it's the brightest jewel in our night sky, a serene beacon of light. For millennia, it was the morning and evening star, a symbol of beauty. But this gentle facade conceals a reality of unimaginable violence. Beneath its unbroken, pearlescent cloud tops lies a world that is arguably the most hostile in our solar system. Venus remains one of the most enigmatic worlds we have ever observed. Its thick, perpetual clouds of sulfuric acid hide a landscape forged in cataclysm, a surface shaped by fire and crushed by a pressure 90 times that of Earth's. The story of Venus is one of veils, and we are only now learning how to see through them. Throughout our journey, we have explored the profound scientific puzzles Venus presents. Its atmosphere, a toxic brew of carbon dioxide, defies expectations, spinning 60 times faster than the planet itself. We've delved into its history, a tale of transformation and loss. Evidence suggests Venus may have once been a temperate world, like a young Earth, with vast oceans of liquid water. But something went catastrophically wrong. A runaway greenhouse effect took hold, boiling the oceans away and trapping heat until the very rocks on the surface began to glow. This atmospheric furnace, reaching over 460 degrees Celsius, serves as a stark cosmic cautionary tale, a glimpse into a climate endgame that sharpens our understanding of the delicate balance on our own world. And what of the ground beneath those clouds? Radar maps have revealed a world of immense volcanic plains, towering volcanoes, and strange geological features called coronae that exist nowhere else. Yet, unlike Earth, Venus shows no signs of plate tectonics, the engine that constantly reshapes our planet. Is Venus geologically dead, a planet frozen in time for the last half-billion years? Or is it merely dormant, with volcanic activity still rumbling beneath its crust? Answering this is fundamental to understanding why Earth became a haven and Venus became a hellscape. Yet beneath the veil of scientific inquiry lies a story of deep mythic resonance. For as long as humans have looked to the skies, Venus has captivated our imagination. The ancient Babylonians associated it with their goddess Ishtar. For the Greeks and Romans, it was Aphrodite and Venus. In the early days of science fiction, before we pierced its cloudy veil, Venus was imagined as a lush, tropical paradise. The scientific revelations of the space age shattered this dream, replacing it with a far more terrifying and fascinating reality. The story of Venus in the human mind is a journey from idyllic myth to harsh science, a reflection of our own evolving capacity to understand the universe as it is. Now, after decades of relative neglect, humanity is turning its eyes back to Venus. We stand at the threshold of a profound rediscovery. A new fleet of robotic explorers is preparing to return, heralding a renaissance in Venusian science. NASA's Veritas mission will map the surface with unprecedented detail. Its sibling mission, Da Vinci Plus, will take a daring plunge, dropping a probe through the crushing atmosphere to taste its chemical composition. They will be joined by Europe's Envision orbiter, designed to provide a holistic view, linking its deep interior to its turbulent atmosphere. This is a coordinated global effort to solve the planet's greatest mysteries. The planet that once seemed too hostile to study is now a frontier of insight, but the challenges remain immense. To explore Venus is to wage a war against physics itself. The extreme heat melts lead, while the immense pressure can crush a submarine. The Soviet Venera landers of the 1970s and 80s, marvels of their time, survived for mere minutes before succumbing. The engineers behind today's missions are pushing the boundaries of technology, developing new heat shields and high-temperature electronics to withstand this brutal environment. Each piece of data returned will be a testament to human ingenuity. So why do we go? Why face such extraordinary expense and difficulty? Venus beckons us not with the promise of finding life, but with the deeper allure of understanding. The answers hidden there are not just about Venus, they are about all rocky planets, including our own. By understanding how and why Venus lost its oceans and developed its runaway greenhouse effect, we can build more robust models to protect Earth's climate. By studying its unique geology, we learn about the different evolutionary paths a planet can take. It forces us to ask one of the most fundamental questions: what makes a world habitable? The line between a paradise and a furnace may be thinner than we imagined. In this grand pursuit, we may find not only answers about planetary science, but profound reflections of ourselves. The story of Venus is a mirror. It reflects our ancient capacity for myth-making, our modern reliance on scientific evidence, and our future aspirations for discovery. It reminds us that our own planet is an exceptionally precious anomaly. As we prepare to once again pierce the veil of our sister world, we are not just exploring another planet. We are seeking to understand our own origins, our own vulnerability, and our own place in the cosmos. The morning star is waiting, and its secrets will, at last, be brought into the light. Until next time, stay curious and keep looking up.